Hello, my name is Peter Bartholomew. I'm recording this video clip in response to a discussion on LinkedIn raised by C.A. Viswanathan. He was looking at loan amortisation schedules, and one of the problems that comes up there is the problem of cyclic referencing once as you try to use dynamic array methods. So what I wanted to show this evening is one or two approaches to overcoming that challenge. Since I know nothing about financial modelling whatsoever, I will use the same model here as was used in the discussion. We have a loan amount, interest rate, repaid over a number of years, and then the payments PMT function will provide the amounts of uniform repayments over the period that are required. And now I just want to flesh that out with the model. To start off with, we go for the opening balance, which will depend if period 1 is different. So if period equals 1, then we want the loan amount, and otherwise at the moment we haven't got a clue, so just leave those as false. The interest due is the opening balance multiplied by the rate. So the first one showing there was a subtotal there, equals opening balance plus interest. Don't propose to use that. Then we have the repayments, and if it during the periods of the loan equal to if period is a number, then we want the PMT payment value. So that gives the uniform payment across. The first closing balance is reasonably straightforward, equals opening balance plus interest minus repayment. So far so good, that's year 1 done. So next we want this to be an array, so just adding the hashes to the anchor cell names. Get that. The other figures are meaningless because we haven't closed the loop to go to the opening balance up here. So let's do that. And period 1 is the loan amount, and subsequent periods are offset, and they're based on the closing balance, no row offsets, and the previous column. So entering that and putting the we're immediately into a circular reference. The simplest way of dealing with that is to go to File and Options, Formulas, enable iterative calculation, and that's the correct calculation. Could leave it at that, but when I proposed that with a study that Lance Rubin was putting together, he nearly threw a fit. Never would he ever allow cyclic references. He had had some very bad experiences. So what I want to do next is demonstrate an alternative way of dealing with the problem, in which to build a cumulative repayments, and rather than taking each repayment of the previous balance, take the cumulative repayments directly off the loan amount. So that's the next stage to look at, and to get a cumulative repayment, let's have a look at what's the possibilities there. If I take a particular period equals period, and the one on this column is given by that, period 4. What I'd expect period 4 is to see the sum of the 4 repayments. Today, before I do that, I will simplify things and put that back to 0 interest. So there'll be repayments each for 1/5 of the principal. So to get the formula that picks that up, we want equals and more offsets. The repayment array, 0 row offset, 0 column offset. The height, we want a single row formula, and the period gives the number the width. So let's see how that comes out. Looks pretty good. You wanted 4, got 4, and now if we wrap that in sum, then we've got the 80,000 that we need to deduct from the 100,000 to give 20. So it looks like we're going well here. If I now just copy that across and out, that's the cumulative repayments. Now there is a catch, that I don't want to do this as a filled array, sequence of numbers. I want to do it as a dynamic array, so remove that and go for the whole every period, and unfortunately you only get the single value, which is the final value. So sum won't do what's required. Turns out that sum if will be do what's needed, and a very straightforward condition really is that provided that the amounts we're summing are not blank, then we want to sum them. So that has summed 1, 2, 3, 4, 5. So doing fairly well there. That enables us to change this formula. So instead of the cyclic reference, we can just remove that, and that will be equal to the loan amount minus the cumulative repayments as an array, and we get the same answer but for different formula. Instead of the corkscrew, it has just accumulated everything and subtracted from the loan amount. So, and just to demonstrate that things have worked, go back to options and formula, disable the iterative calculation, and everything's still okay. So this solution doesn't require iterative calculation. Of course, we still have a problem because we haven't allowed for the interest. If I put that back again, then everything still works, but it doesn't give the correct result. And it turns out that what I need to accumulate now is not these figures. They are the amounts you would need to set aside at the beginning that with 6% annual would have provided sufficient resources to pay the increment of payment. So that is equals repayments, but factored down. So there's a by 1 plus the rate to the power of period. And that gives a set of figures which you see declining. So it's going to be a smaller, the cumulative total is going to be smaller, which is what we want. And this 17, for example, is the amount you would need to set aside in thousands in order to be able to pay 23,000 in the 5th year. So switching the cumulative repayments now from the total repayments to these initial values. So switch them to the initial value, get a different set of numbers that do finish up at the 100, does solve the model. So what I've shown is two distinct approaches, one permitting circular references and the other a trick by which you work out cumulative totals by going back to the beginning each time and adding a bit further using offsets. It's not a computationally efficient method of performing the calculation. It's also volatile, but problems of this sort, it works well. It's fine. Hope that's of interest, and leave it there for now. Bye.